Hi everybody, this is Andrei. Today we will continue the series of our tutorials about Luma-mu and integrating it into the modular setup as a synth channel. And I already had several videos about that, how you can control it with a CV voltage and how you can create your own custom waveforms. So we will continue that route today, and rather than focusing on a drum channel, which is more or less straightforward, we will do some advanced features on the synth control and how it could be used in a full modular setup to create a polyphonic synthesizers. So stay with me. It won't be, well, easy, but I'll try to make it less complex to you to consume. So first of all, just to remind you, so this is the Luma-mu, and we have several ways to externally trigger this module. So first of all, well, there is a trigger button, and that's what, well, I already went into the overview of this, and there's a pitch control dynamics and a sample select, all of that known parts. But the thing is that when you try to integrate it into the synth setup or into something which is not a drum design, right? So because this module replicates the LM1 Luma-1 channel, so it's originally a drum channel. What it means? Well, of course, it has the 8-bit DAC on it, and it has the EEPROM, but the truth is that it's designed based on the principle what was needed for the drum. And specifically, in order to clock this module, there is a series what's called 555 timers. So it's very known timers used in everything from hobbyist electronics to the most advanced things. And this 555 timer is controlled by this potentiometer. And basically, you set the frequency of this timer by setting the resistance of the potentiometer. So what I'm saying that it's not thermally compensated, it's not stable, and of course, it can vary over the time with all of the environment conditions and so on. So when you apply the CV voltage, and that's what I did in one of my early videos, well, you have a limited range to control it, first of all. This range is not linear, and this range will also drift from time to time because things are changing, the environment is changing, the components get hotter, and so on. So today we will look at a different way how you can control this module precisely and always stay in tune without going into the Midi or USB or that sort of digital communication stuff. Still will be controlling it with, well, let's call it sort of like era-rec principles, but make it very reliable, robust, and with no tuning required. So for this, when originally Jobrit and I looked at this, there is a special clock input. I talked about that a little bit, but now I'm going to explain how to use it. So there's a clock input on this module, and that is basically disables that internal timer that otherwise creates and generates that clock. And that is externally feeded by the external clock. How quickly all the simple logic starts taking the sample from the EEPROM and playing it to the DAC. So basically, it determines the sample rate of the DAC to play a certain waveforms that's stored in the EEPROM memory. And again, refer to one of my previous videos, depends how you created these looped waveforms. Well, for instance, if you're in loop mode, right? You may spend a different number of samples per cycle. So you can fit a different number of cycles into the capacity of this EEPROM, and this determines the root pitch, but the exact pitch will be determined how quickly you start scanning over this and providing the clock input. So the trick is that that clock input is relatively high. So, and this is just a square input. In a basic way, I can grab something from the modular setup, like a VCO, generate a pulse, and it will start scanning and already start working. The question is, would it be enough of a range of that VCO to go outside of really the 20 kilohertz and go to the beyond what is in the hearing range? So let's take a look at that first. I will give you an example of that. Now let's take a look at my setup here. So I have the ear rack case with multiple Luma-mus here, and each of these Luma-mus, they have a Luma reach around module. And in the Luma reach around modules, I have different ROMs here. We will be using these later. I will show you examples of these. Also, what you'll find unusual that they have additional switch, so they modified, and the reason for this switch that I just extended the jumper header that is here, and this jumper sets the mode of operation to the single shot sounds or to the loop mode sounds. So in the loop mode, you're constantly playing the sounds, and that's what we used in the previous videos to drive the wavetable oscillator for synth mode. In the single shot sounds, typically use it for the drum sounds, but also I'll be using some synth sounds with a single shot as well. That's why I thought it would be handy to have it. If you think the same, well, let me know in comments, and I may include that into all the production versions as well, or give you some upgrade kits if you want to drill the hole yourself and put just a little switch. So that is just super easy to do. Also, we have the, so that's my Deft Audio MIDI interface. So it's a 1U, 8 MIDI input and up to 14 MIDI outputs interface module. And the last 6 of these are on TRS, and they are software defined. I talked about this module several times already, really happy with the product overall, and it has the capability on every of these outputs to define what they are. They can be a MIDI output, they can be a trigger output with high current, so it's enough current to drive, for instance, relays directly, or to connect to ear rack gear. You don't need much current, but something like the LED lights or relays, you can drive directly from these modules. Also, it can generate the sync output at different rates on all of these 6 outputs at different tempo that you can control, sending the MIDI clock to the individual MIDI inputs over USB. And so it also has the brand new mode that I'm introducing today that is designed to integrate this module with Luma-mu to precisely control. I don't want to go to this at the moment, so let's start with basics, and let me just show how you can drive the external clock input from some other gears that can produce this square wave. For this, we'll take the 2600. That's what I thought would be really easy to try because everything is on a panel here. You can see what I'm doing. I will take this module, so this would be I set it to the loop mode. The ROM that I have here called sines ROM, so it's all sines. They have same root frequency, so it's the same number of samples per cycle, and they just have different harmonics. So let's grab this. When I connect the clock input, even though I have nothing connected here, it interrupts the internal clock generator circuit that we talked about, 555 timer. And so now I can take this and I can patch it to the pulse output. And we really want to have it in a square wave, so we set the pulse width to a 50%. And you can see that's already the signal coming here because it's currently at the lowest frequency and it's already generating the clock reference for here, and it starts playing slowly. And because it's so slow, obviously it's outside. Well, it just, you hear some noise out of this. So now, because I'm not triggering it with any MIDI keyboard. I need also to patch this CV input. And I'll take this CV input from the processor from here. And so by doing that, I'll be able to control the voltage applied, and that will determine my upper frequency. So let's put it up. So that's how easy it is, right? All I'm doing is basically supplying the clock. Now here's a problem, that if I patch it back and I want to hear this, I hear nothing. And the reason for that, because I'm already outside of a frequency range. So you really need to have the oscillator that is capable to drive over 20 kilohertz and get to the sample rate frequency. And while not every oscillator is capable to do that, first of all, and not every oscillator is capable to have a control when you play it from the keyboard. So you might end up just really playing at the lower range and not get to the high range because you are not able to generate that high sample rate frequency. And really what I'm showing here is, well, let's call it a hack, because I'm using the analog voltage oscillator, right, with the external control to drive the square wave output that I'm using for the digital circuitry. And that's not really in a digital way of doing things. Well, it's still possible, and that's easy to tune, as you see, but it's not the right way to do that. So instead, what we can do, we can take the, well, let's say, digital clock, the superb timings, and feed it directly into the Luma-mu. And that's what I'm going to show you with the Teensy interface. So I think this is a way to go because it gives you more flexibility. Let me show this. So now we're switching over to this Teensy interface, Midi interface. I know it's hard to see the screen from this camera, really apologies for this, and I will make just shots of the photos to show you what exactly the menus I'm configuring, but I have to read it back to you so you know what I'm doing. So it has open source firmware. And so any modifications that you want to do yourself or you have capability to do, you are welcome to do that and contribute back. So that's totally up to you. If also that you want to take this functionality and integrate it to other modules, you can do it yourself, or let me know how you want to see that, because I'm really looking forward how we can use that to create a really large polyphonic synthesizer. And this module already has capabilities to play multiple Luma-mus polyphonically. So let's take a look how we configure this. So we have 6 outputs, as I mentioned, and not only MIDI triggers sync and Luma-mu, there are different modes how we connect it to the Luma-mu. And for this setup, we will be using this module that's playing from a picarom, and we will be playing a single shot sound because I think that will give us more flexibility to demonstrate what exactly we can do with this. So let me trigger this. So it has some synth plug sounds, it has some Fairlight sounds on it. I'll play it later, you will hear it. So now we go to this configuration, we press menu, and this is how we, hard to see. And this is how we configure the port value. So for the port 9, we select what this port is doing. And there are multiple modes. So there are 7 total modes for these ports. MIDI, trigger, sync, we skip this. Now clock. The clock output is exactly what we need. We just feed the output of this TRS into the clock input of this module. And so now when I am playing the MIDI notes that come into here, I'll be providing them, I will be generating the clock output to this module. Okay, so that's, we configured this. Now for the port 10, again, I can configure that to be another clock. And as I said, I can do that up to 3, so I can drive 3 modules at the same time playing polyphony, full polyphony with full round robin and voice stealing, fully supported. But I also need some other signals, especially when I play the single shot sounds. I can configure it to the gate, so that's currently set mu gate, and I will connect it to the gate input. Then we'll take the next port, and the next port, again, I can configure it to the to the gate, or I can configure it to pause. There's a pause input. And what pause is doing, basically, whether you're playing the sound and you send the note off, you stay in this position. And we did that when I had a video of recreating the hi-hat where it was looping and we were triggering in different places. So same could be applied to the wavetable oscillators, where we start in playback at the position where we previously left it. So we will do this, and we will connect it to pause. And the next port, that would be port 12 here, we will configure to another mode called reset. So you see that in total you have reset, pause, gate, and clock. So 4 modes to control Luma-mu, and I will connect it again here and connect it to reset. I want to tell you that you don't need to have 4 cables connected each time. Otherwise, it wouldn't be possible to play 3 modules with polyphony at the same time. But I just to show you what are capabilities, because I think this is really important to understand, because it gives so much flexibility in the way how you can drive it. So then we skip the 13 and 14. We don't need to configure these. We'll skip the configuration for the sync output, and now we get additional parameters. So the first parameter we set, it's called TRS trigger MIDI channel. So that's a MIDI channel to trigger TRS output. Since we are not using them, it's currently configured to the channel 10. We just leave it as is. The next MIDI channel is for Luma-mu. This is exactly how we are driving these. So you set the MIDI channel that we'll be using for this data. So it's currently set to the MIDI channel 1. Then we have 2 options to configure the tuning. Why do we need tuning? Well, first of all, if you're already dealing with the accurately mapped waveforms, like in the video that we created previously, you don't need to deal with tuning, because everything is in power of 2 and everything is already mapped precisely. So all the MIDI notes that come in here translated to the exact clock rate that's coming to the module, and so everything is playing in tune. You don't need to worry about this, so you keep just that in 0, and it sets the offset basically for the tuning scale. However, if you are dealing with some, let's say, audio sound that you captured, and you captured that at a random frequency, at random pitch, so you want to adjust that pitch, and you can do it from here by adjusting the clock output. And in that way, well, for instance, I don't know, I can tune the drum sounds to be playable over musical keyboard, or I can just take some random frequency and really tune it to the keyboard as well. So, but there are 2 parameters, and one is rough. So it's in the order of 100 Hertz clock rate change. And the second parameter is a fine tuning. It's in the order of a single-digit Hertz change. So that gives you a really wide range of the capability to adjust that clock, and so you can fine-tune it precisely. Then the next parameter, called bass octave. What bass octave is? Think about this. When you have, like in the loop waveforms, so you have a cycle taken the certain amount of samples. Let's say it takes 128, 256, or 512 samples for the single cycle. That at the constant sample rate frequency will determine your root note. And this is what base octave sets you. What is that multiplier? So I can set the sound to the right octave. And well, obviously, if you have the waveform that's taken, let's say, 512 samples, it will take longer to play that waveform than the waveform that takes only 64 samples at the same sample rate frequency. So you have to adjust this. There are pros and cons, because if you take a waveform that takes only 64 samples, you can put more cycles into the given ROM capacity, but it will have less precise data in it, right? So when you start playing it, it will play up to the higher frequency range, but you will also experience more aliasing and more side effects of the DAC. If you take otherwise the cycle that will take more samples, let's say 512 bytes, first of all, in order to play it at the same pitch, you have to drive this DAC at much higher sample rate frequencies, and so you may say, I lose some character of a DAC, and at some point you may run out of a DAC capabilities. So this is, well, these DACs, 8-bit DACs, they handle it pretty well, but the sound character is changing, depends what is your root node is. And so I thought it would be good to show you these examples. All right, so now let's look at the other options. Next option called pitch bend range. It fully supports pitch bend. We will play it with pitch bend. I'll show you examples. The last one, again, I have to spend a little bit of time explaining this. This is why we might need 4 cables ultimately, or only 2 of them or 3 of them, depends how we drive it. Because think about this, when you have these single shot sounds, at the end of a sound, you want to go to the original position, or you may want to pause it, or you may want just to stop providing the clock. And on the not on, you have to trigger it again, and that's why you may have a trigger cable. But basically, this menu explains what you are doing at not off. So you have several options. You can stop clock, just everything is coming, and you have a not off, you stop the clock. What's the consequence of that? Well, first of all, that the sample stayed at that position where it was before, and it stayed with some DAC voltage that typically the analog gear compensates, because there's also capacitor on the input, so it compensates the DC offset. But you have to remember that at that time you're staying somewhere in the middle of a sample, and if it's not crossing the zero, it certainly provides some DAC voltage out of it. Then the other option, you can, instead of stopping the clock, you can continue providing the clock but trigger the pause. And trigger the pause also will light up the pause indicator, so it might be really great to see when you stop, and that you'll get a visual indication that you're really currently in this pause mode. Then at the not off, you can set the reset. So that would be example if you're playing a single shot sound, you send a not off command, you reset it to the 0 position of a sample, and at that point it's 100% the DAC is muted. So there is no DC offset, the DAC reverted to the 0 position that has a 0 voltage out of that, and in addition to that, the DAC mute circuitry also triggered, so there is no sound at all coming from this. So, and the final mode, you can send all of that at the same time, and just depends which cable you connect, you will trigger one of these modes of operations. All right, so let's save it. To save it, we just go to the exit menu and press the sign button. Now it saves and it restarts because it has to implement these parameters. Some of these parameters could be done in real time, others cannot be. And from this, now you see it's booted, and it shows you the voice configuration. Again, I have to read it to you. So we currently have, I need to look at my configuration again. So we currently have 2 voices defined. One goes to the clock output 9, gate output 10, pause output 11. And on a voice 2, I set clock to the 12. So I probably did a mistake when I was speaking so much. So we go to, exactly, we go to the output 12 and we set it to the reset. Let's save it again. And that is handy because when the unit boots, at least you know what is the configuration currently set, because these are really assignable. So now it sets to the single voice, total voice is 1, so clock on the number 9, then gate 10, pause 11, and reset on 12. That's exactly how we connected it. So now let's look at the computer and the keyboard and start playing this. Okay, so now I made all my USB connection here, and let's look at my screen. What I have, basically, I'm not running any DAW or sequencer here. I thought it would be much easier to give you a demonstration with just a simple tools. And for this, I'm using the package called Midi pipe. It's just a basic routing tool that give us the result much quicker and easier, and we can use it also as a monitor, Midi monitor of all the events happening. So currently, if I trigger the note, you see I am playing the sound. That's great. And if you look here, so because our current mode of operation, we are sending everything. So we send in this pause, we send in the reset. So we always go back to the sample 0 position. The Luma-mu is set to the single shot sound playing, no looping. And we trigger the trigger input. So every time we play the new sound, it triggers it. So when I play it, you see that the dot disappears. So that's the pause dot. And so I can play it. Obviously it's a single voice, but there's a voice still in. Okay, so that is working. And so what we can do with this? Well, first of all, exciting that it's working, right? We can play the sound, and pitch is supported, and so I can play it as usual, and that's fully in tune, because my original sample was in tune, and so I don't need to tune it again. But it depends what is root note you pick, of course. You have to keep that in mind. So now what I'm going to try, I want to implement some additional functions to that. And for instance, I want to take my gate that triggers the trigger input, and I want to take this gate, and I want to use 2600. That's why I'm staying in this corner to show you the demos of 2600 as well. And we will take this gate output. We will send it to mult, and we will take it back from mult to gate here. Okay, still working, of course, it will. Now I will take the gate from here, and I will connect it to the envelope generator. So every time on gate, now I'll be triggering the envelope. Nothing's happening, of course. And I will take the envelope output and feed it back. And I have several options, basically. I can feed it to the dynamics, and then basically it will make a VCA out of that, because dynamics is controlling the reference voltage for DAC, and that is effectively your VCA. Or I can feed it to the sample select. So let's do sample select. Let's see what levels we have. And we need to set the offset potentiometer. I like this. So you see what is happening currently, right? So I'm feeding it back and it controls the sample that I'm playing. And since not all the samples, but most of them were from the same pitch, basically I'm scanning through the waveforms here. And that's just one of examples how you then integrate that to this setup. I found it, well, it's cool. Let's hear all other samples that we have here. That's what we heard. Similar, but slightly different, so I can alternate between them if I feed it, if I feed the envelope back and give it less range to the sustain level. Basically, I will provide the less voltage output of this. So that's one of the Fairlight sounds. Oh, that's certainly Fairlight sound. You can hear it by the amount of the noise. That is Fairlight marimba sound. That's another marimba. That is some sort of like Fairlight piano process sound. That's also from Fairlight factory library. And that is just one of the sounds that I did in Ableton. Anyway, I think that's a good demonstration how you can control a single voice, and so you can really start integrating that as the in your setup as the oscillator, perfectly in tune all the time, and managing all the samples and having picker on that I have here. You may see that that's the whole samples that I have that already played for you. Yeah, so I can manage that in pretty much real time and upload the new samples, and so use it. That's really impressive. That stays in tune and doesn't need to have all the complexity of the CV syncing and tuning, which, as I said, you still can do that with the CV voltage. You get less range and it has to be compensated because it's not linear. So some products like Expert Slippers, this FH2 or their Silent Way plugin pack is needed to adjust to this. Well, okay, so now from this, let's go to the next level, and let me configure the 3 Luma-mu with the three clock outputs, and I'll show you something way more advanced than now. Now on the next demo, what I did here, I took the 3 outputs, so 9, 10 and 14. These are the outputs that are capable to generate the individual independent clock outputs and really perform as the polyphonic synth with a full voice stealing and round-robin voice management. And I mentioned that already, I know. So I just connected the clock output of the first to the Luma-mu first, then second and third. So we'll be using only 3 of these. They all have the same sound ROM, so that's these sine sound ROMs. They set to the loop mode, you see here. Also, I triggered them. So I triggered, and because it currently doesn't send any clock, it stays where it was. And ultimately, if I triggered that, then everything was off, and it just turned it on. They all will be staying in the 0 position. So with this setup only, I can start playing it polyphonically. Okay, so yeah, did I play a chord? Great. With that, I can really play with this. The caveat here is what I explained earlier, that so because I don't have any other parameters, there's no ADSR, I'm just, think about that, I have a sample and I just start playing it and then I pause. So I'm sending DC offset to that mixer that hopefully compensated, so I don't see it here. But it's still, it's a very rough way to do that, right? Because we have no ADSRs, we have no proper, well, pausing and so on. And ideally, I should do that in a different way. However, what I can do, I have 3 additional outputs, and these 3 outputs could be a gate per channel. that I can then again feed to my 6 envelope generator. Feed it back to my 3 envelope generators, and so I can supply the dynamics, return it back into the dynamics input, and in that case it will be a full VCA. That would be easy way to do. I don't have 3 envelope generators in this setup here, but what I have instead, yeah, it's slightly more complex, I know, but let me show you this, how I can propose this, and you will see the result that will amaze you for sure. So I have Expert Sleepers FH2, and I'm using that for quite a long time already. I really enjoy Expert Sleepers product. I've been talking about this. This is one of the hardest learning curves for the products because there are so many options. They have great manuals, but you have to read the manual that is like 50 page. So you have to know what you are doing. But once you know, it helps you a lot. The problem that when yesterday I started preparation to this video, everything was working and just suddenly it failed. And what failed in this is the USB input. It started overheating. There's IC that's managing the voltage, and just suddenly it broke. But the module is still operational. So if I press it, you can still see it. So what I'm going to do instead, I will run it, instead of providing this over USB, I will run it over the standard Midi, and I have my own that is the Midi through module. So it's just that little one input for Midi outputs that I'm using. I internally connected these together, so because this one doesn't have the physical inputs, it has to be on a breakout board, so I'm using my module as a breakout board for this. What I'll be doing with that, I'll be sending the Midi data to this module, but in addition to that, you will see how I set up the Midi pipe program. So at the same time, it will be sending Midi notes here, and this module will be generating the missing envelopes for me, right? So I'll be using that as actually 3 envelope generator that I will supply then dynamics, and we'll do some other cool stuff with that, all right? Okay, so let me quickly connect that all together. Also, I'm using another module of mine. It's just a simple DIN5 to the TRS with TRS-A or TRS-B configuration, and I found it makes things really much more convenient, and that you can manage with. You don't need to think what cables you connect. So now let me look at my screen here. In the configuration page that you can see here, I just opened, that's the web-based editor for this Expert Sleeper module. So let me gather it first. So I requested the version and it replied to me, so means the Midi communication is working. Now I need to take the configuration file that I created and I need to load it. Okay, I loaded it. So what it's currently doing, I set it to the polyphony of 3. That's what you see here. I'm generating the gate and envelope per voice, and I can also control these envelopes. Let me see, where is that? So first of all, I have also 2 expander modules here, but we don't need to look at that. And I can see also my envelopes. Where is that? Oh, that's here. So I have my envelopes that currently set to the also to receive the CC messages on the CC 1, 2, 3, and 4. So that will be attack, decay, sustain, release. That's why I have that rotor control module, because I'll be able to do that. But if I take all what that happened right now, so go back to my Midi pipe setup, I have a Midi input coming from a Prophet or Prophet 5. Then I have virtual keyboard, I'm not using it, virtual slider, Midi monitor. Then I have first Midi output, that goes to the Teensy, so it goes to the port 16 on Teensy by default. That's generating all of these clock references. And then next to that, I have another MIDI output that goes to my USB interface that, I actually thought I could use this the same as a USB interface at the same time. I don't need that other one. That's handy. And so that it's generating the trigger signals for these. So with that, I have to set one to pass through. So I'm sending the MIDI notes to two outputs at the same time, and that is quite unusual for the DAW setup. But basically, most of the DAWs today, you can set up that like in Ableton that it will be sending to the two individual outputs, MIDI outputs, because it will be listening for one input. That's not a problem. So now if I press the note, I want to transfer my configuration to FH2. Okay. So now if I press the note, what happens? So you see on my Expert Slippers expander module, all the magic happens here from 1 to 6. And the first one is the negative gate. I will show you this. And then you have the envelope on each voice. So I set it to 3 voices. 2, 3. 1, 2, 3. That's all we need. So I will take this envelope and now map it to dynamics. And I set the potentiometer in the middle. Well, it's handy that it also has a center detent position, so I don't really need to see it. And then I will connect these to the second one, and I will connect these to the last one. What it gives me? Well, first of all, now everything is controlled by envelopes, and I can implement the envelope shape to the sound, so I can shape the sound, but also I can mute the sound. So even though I'm not sending any of the reset or trigger data, I keep sending the clock, and at the end of my envelope, I just mute apply the negative CV voltage here, so that's effectively mutes my DAC. And with that, that would be my polyphonic setup. The problem with this setup currently, that I'm not sure the voice assignment. So even though this one operates in the round robin, this one operates in round robin. So the voice 1 and voice 1 here could be at a different place, because you see I turn it on later than I already played with this. So I need to turn off everything, or just to make sure that I am at the last voice and then turn off these. That would be much easier. So then the next note that I'll be sending, it will go to the note 1 on both of these. So let's see. Also, let me check the configuration here. So I'm sending clock on the port 9. I'm sending clock on port 10. So let's go 11, 12, 13. We don't need it. And on the 14, I'm sending also a clock. That would be that. And let's save it. It will restart. Actually, I should scan it and then do restart. So let's see. If I play the note now, it's working. So I was able to hit a voice 1 here. So basically last time I stopped at voice 3. So at the time I configured this, it has been waiting for the voice 1, and now when I play the sounds, fantastic. However, here's a trick, and that's why we needed several modes for operating what happens on the not off event, because let me, okay, I stayed on the voice 3. So if I go here and look what is our current mode of operation, you see I send stop to all, including that I'm stopping the clock. And with that, because I'm stopping the clock, I have nothing happening on the release time. So when I send the note off, that's supposed also to continue to the release if I configure it that, right? But now if I play this, it just stops. Instead of that, I don't want to stop the clock, so I configure it to some different mode. Let's say I'll be sending a pause, even pause I'm not using. And you see what happened, right? So now they all sound, and this is where I can adjust my offset to mute them. Now I adjusted that, and let's play it. So you can hear the sound in the release, and I think I still hear some sound in the background. Yeah, that's it. That was that channel. And of course now I can also send the CC messages to control this. So for this I need to add additional MIDI input. And from this MIDI input I'll be taking it from the rotor control, and so no attack. Oh, it's hard to play when it's in different octave. I think it's just a good example of that. All right, of course, it went much more complex than I originally anticipated, but I'm so glad that I was able to show you all of this working in a setup that you can configure, that you can look and really create the polyphonic synth with Luma-mu and integrate it with my other products. And again, well, if you like it, leave a comment. Leave a comment what you want to see, because I'm currently thinking of the dedicated error rack module that we can do for the controlling multiple Luma-mus, or maybe this will be enough. I don't know. Just leave in the comments your ideas, what you want to have, and I'll be happy to check every single one and reply to all of them. Well, thanks a lot, and see you next time. Goodbye.